All right, let's get started. Room's closed. So hi everyone. Welcome to our session on deploying a modern data platform with SQL Server 2019 on the SUSE platform. My name is Vin, and sitting in front of me is Amit. We both work on the SQL Server product team. So just a few questions before we get started here. How many people have used SQL Server before? Okay. Okay, sounds like most of you. How many people are using SQL Server now, somewhere in your organization? Okay, are you guys running this on SUSE? Trying this on SUSE? Okay, one. Okay, this is really good. Great. How many people have tried it? Like maybe not running it, but you've tried installing it, just a package. Okay. So you guys went through the package installer or some sort online. Okay. And because we're going to actually have a lot of demos here with containers as well, who here is familiar with containers, Docker containers, any of those concepts? Great, that sounds like most people, so it's going to be amazing. We're going to start merging those three pieces together throughout our journey here today. So let's just get started. So the way we're going to go about this session, we're going to talk about SQL Server is really by telling you what customers have been telling us. And specifically what they're trying to do with their data and organizations, as well as how SQL Server is helping them with some of those challenges. And along the way, we'll have some demos, primarily what I just mentioned with SQL, containers, as well as SUSE. And this is going to illustrate to you how customers is using this technology to help solve some of these challenges. Right? So often, our customers do provide a lot of feedback to us, and they do tell us what they're doing with data. Recently, what we have been hearing a lot of, on a high level, and for the purposes of this session, there's really two categories here. One of them is data as a service. We're hearing a lot of customers build out a data as a service in their organization. And the second one is managing enterprise data. Right? So let's just go into what that is, the first one. So many of our customers are trying to build a data as a service in their organization, and primarily for the purposes of not just production purposes, but development, tests, DevOps, app deployment. So who here is, just to get what kind of role you guys are in your company, who here is more of a developer? Okay, what about admins, or more on the administrative side? Okay, neat. And everybody else? Sounds like there's only like half covered so far. I don't know. Okay, all right. So if you look at why companies are actually developing a data as a service in their organizations, is because often administrators, primarily in IT shops, they're responsible for not only production environments, but all the other environments in between, right? From development, throughout the development, application development cycle. So building a centralized data as a service is going to help companies so that they don't have each team building out their own infrastructure, their own, for example, the dev team's not going to have their own data infrastructure, the test team's not going to have their own data infrastructure. If you have one team building this out, you're going to prevent duplicate work, as well as have this in sync across these different environments as well. So when building out a data as a service, if you are a centralized team and you're responsible for all the developers, all the environments, you need, when you're building such a service in your organization, you need ease of deployment, right? Low maintenance and high automation, right? So the way a lot of these customers are building out data as a service is with containers, right? So what we've been seeing a lot of customers come to us recently, especially the last 2 years, is, hey, how do I do this with containers, or how do I do that with containers? And when we ask them, okay, well, why are you using containers? These are some of the reasons why. These are the properties or characteristics on why you would want to use or want to build a data as a service in your company with containers, right? So let's just quickly go through this, and we'll also see some of these properties in our demos as well. So first of all, it's isolated. So when you have a SQL Server or a process running in a container, all its dependencies, the process itself, are not impacted directly by another process, and that's dependencies as well, right? So the second one is consistent. Every single time you spin down a container and you start it back up, as you may know, the container starts in an exact same manner, right? It doesn't start in a separate way. It doesn't save a state. It starts in a very consistent manner. Third of all, it's portable. Because a container ships with all its dependencies, whether you choose to run it on one computer or another computer is going to run the exact same manner. In fact, it runs the same on-prem as well as it does on cloud. So today, if you're you're adopting a strategy where you can containerize your workloads, tomorrow you could lift and shift and bring this to Azure fairly easily, right, through the services that we have there. And the next two is ease of use and ease of starting and stopping. We'll see this in a bit. For those who have tried, it sounds like most of you have tried out containers, it's really easy to spin up a containerized process as well. And last of all, there's no installation. Now, I think on SUSE, the package manager makes it really easy to already install software, right? But with containers, I really think this takes up to the next step because you could customize your package really easily. Not just deliver the package, because building a package takes some time, but building out a container is really simple. And using this organization, shifting that container around is really really easy. So with that, let's go into some demos. I'm going to change my screen here. Okay. Like I said, you guys can see my screen? Great. So I apologize if some of these demos appear to be a little slower, partly because I'm rendering it onto the terminal and I'm just limited by the internet here. So the first thing I want to share with you all is how do you build a SQL Server on a SLES container, right? So let's just go here and take a look at this one file. So this is my Docker file, and this specifies how to build a SQL Server on a SLES container. So here I have a bunch of comments, and I'll highlight the more important parts and the parts we want to talk about. So this is going to start with SLES 12 SP3. So this is the base of your container. So everything I'm building on is building on top of this container, and this is available through the container module on SUSE. Right. So the next thing I'm going to do is I'm going to add the repositories, right, the zipper repositories, and I'm going to install SQL Server. So these three steps are no different from how you would normally deploy SQL Server on a VM or on bare metal. These are exact same steps. So adding the repo, refreshing, getting the keys and refreshing it, and then last of all, but just a simple zipper install, right? So very similar steps. The next step is to copy over the configuration file. So if at start time, if you want your SQL Server to start up in a certain manner, for example, have certain features enabled or have SQL Server look in a different directory, you can just specify and change this configuration file, right? So every container is going to have this config file because I'm copying it. The last two steps here is I'm going to expose 1433. This is the default port in which SQL Server listens to within the container. And last but not least, I'm going to run this SQL Server process. So with that, let's actually build this image. So here, I'm going to just run a Docker build. And this is the file I just showed you, Docker file 17. I'm passing in the file, and I'm going to call this MS-SQL 2017 SLES. Right? And it's built really quick, thank goodness, because I cached this ahead of time, or else it would take a few minutes just to download the bits. I wouldn't want you guys all sitting here watching a bar scroll. It's not very fun. So here you can see, just like I mentioned before, all the steps that we're doing from SLES. We're adding the repo here. We're adding the keys. We're running the install. We're copying any configurations that we might want. We're exposing the port. And last but not least, we are starting the SQL Server process when this container starts. Right.
Where are you running this?
Excuse me?
What cloud or platform are you running this on?
Oh, this is inside a SLES VM on Azure. Right? But this,
On the Azure.
yeah, but the same steps I could build this as well on anywhere, right? So the
Right, understood.
yes, so this is in the cloud. Actually, I would have preferred to run this locally, but I'm on this machine, a Mac, and I don't have SLES installed locally.
I'm more
Yeah.
impressed that you did it on Azure, so continue.
Okay, thank you, that's great. Yes, so I'm going to run this. So now that I've built this container, oh, here it is lagging. There you go. To run this container, I would just use the docker run command. And for SQL Server to start properly, similar to how it would start on a VM or a bare metal machine, it needs to first, you need to pass in the EULA, accept EULA environment variable. This just ensures that you agree to the terms and conditions when running this software. and 2, specifying a password, which is required at minimum for your server to have admin login. Then I want to map a port. What this port does is indicates that this container will be listening from the host outside the container on 1600. So if you're going to connect to this instance, you wouldn't connect to 1433. You would connect to the IP and the host, which is mapped here. Right? So this allows you to run. The reason why you might want to map a port is that you want multiple containers on your machine. So for example, if I had 5 instances of SQL Server, I could have them listening on all different ports. But if I have them only one port, it would collide. Then I just give it a name. It is an arbitrary name. And this is the image I just built. So you can see that I had built this container image here, successfully tagged. And this is the image that I want to run. So with that, I'm going to run it. Great. So if I do a Docker PS, I can see that this image took a second to come up. So here it is. This is the image. It came up 2 seconds ago. It was created 3 seconds ago. And it's currently listening on port 1600. So I'm going to go. So let's actually connect to this instance. So this is Azure Data Studio. This is a database tool that's available on. Who here has tried this? So I'm not repeating myself. Who has tried Azure Data Studio? Okay, great. So Azure Data Studio is actually a SQL Server tool that works on Windows, Mac, or Linux. It's a cross-platform tool. It allows you to connect to SQL Server running in Azure, SQL Server running on Windows, SQL Server running on Linux, anywhere, right? Because it just connects to that endpoint. So here I have a UI. I can connect to it. So this is the my instance. Notice how I'm connecting to 1600, as I mentioned how I started the container. So I just pass in the password here, and I'm going to connect. Great, so I can see that it's running. So I connect to the instance. So at this point, you pretty much you can use this instance just as if you had downloaded and package installed it. So you treat this the same way. But notice how quick it was for me to start this container instance, right? So so one thing is to note here is that the OS version that the container is based off of is SUSE CaaS 12. So this is the base image in which my container is running. And notice how the computer name here is some GUID 4E and it ends in 7C. This is the container ID that we have. So this is indeed connecting to that SQL Server instance running inside that container. All right, so I'm going to just clean this up. Whoops. So SQL1. So what I just showed you was just how you would do the equivalent of a download and install. So you can imagine in environments, building out a data as a service, how easy it is to easily deploy and manage. Because it only took me a few commands to spin this up, and I'm going to actually clean this up right now by running just 2 commands, docker stop and docker remove. Right. So you can see here that I clean up the container and no longer exists. Right. So another very common way to use containers and what we're seeing in environments is to treat containers as a application component, right? As opposed to something that's long living and from what you normally would expect in a database is you treat it as a component. And what I mean by that is you would start SQL Server as a part of when your application starts up. And the use cases for these is when you're doing development. Right, so instead of keeping a long-living development environment sitting around, as a developer, I could spin up the database, a brand new instance that's untouched, configure it with the correct schema, and then run it, and as well as doing testing. So I'm going to show you what that kind of looks like here. So I'm going to just change directly to my second demo. So, so here I have Docker Compose, and what Docker Compose is it is a tool that allows you to spin up multiple containers as a complete application. I know there's a lot going on my screen. Don't worry, I'm going to walk you through it. So here, there's 2 components. One of them is a database component, and the other one is my web application component. So here, here's my database component. So notice here, I'm using the same image that I just built, MS SQL 2017 SLES, and I'm going to pass in 2 environment variables. Again, what I mentioned earlier, it requires a password and a EULA. Right, and the port I'm going to map to this time is 1500. So in terms of my web application, what I'm going to do is I'm going to build it it is going to first connect to the database instance, create a database, set up the schema that's required for the application to run. I'm going to populate the application with just some dummy data, and last but not least, I'm going to run the web server. Okay, so let's go ahead and get this running. Oops. So you can see here, I'm spinning up two container instances. One of them is the database, and the other one's the web. So here, this is SQL Server starting up. For those who have run SQL Server, this is what you would normally see in your error log. But I have this shown in the foreground just for demonstration purposes. Normally, you would run this in the background as a background thread. So you can see that SQL Server has started up. The application is connecting to it, running some schema to set up that database so that my application can connect. And last but not least, it is going to start this application. So if I go to my browser, I refresh, there you go. So I have an app. This is a very basic table that's connected to my database. Right? So one thing to really note here is, as a developer, I can get my code. I could download it from my whatever source, my repository, my code repository, and then I just stick a Docker Compose file in there. And then as a developer, not only is it easy for me to get my application code, but it's also really easy for me to spin up, to start this application in a reliable manner every single time, right? So I'm just gonna stop these containers. So notice here, every single time I'm done with these containers, I can easily spin it down. There's no need for me to keep it around for other people to connect to it. It's just, for me, I only need it on demand. So I'm going to just down. So in a very similar manner, I can also do the same approach with testing. So if you have a CI pipeline, you could either connect to an existing SQL Server instance that's already provisioned, or you could spin up a new SQL Server instance, set up your test environment infrastructure, run your tests, and complete it. So,
and then tear it down.
yes, exactly, and then tear it down. And this makes it really easy. So you're not keeping an environment around where it's going to, so especially if you're doing this in the cloud, you don't incur costs by keeping an environment around. You just spin it up on demand. Right, so what I'm showing you is I've already at this point started SQL Server twice from scratch. I've torn down SQL Server twice. So let's do that one more time with my tests. So if I'm going to show you, this is another Docker Compose file, very similar to my application. I have my database, and then I have my web app, right? But this time the web app is going to run some tests against it. So let's go ahead and run this. Whoops. So if I pass in, so this time I'm gonna pass in explicitly the Docker Compose file that I want to run. And very similar again, it's gonna create a network so that these two containers can talk to each other. And then then SQL Server is gonna start up. And when SQL Server has finished starting up, it's gonna run some schema migrations, and then it's gonna run some tests. So you can see that you're going to soon see here where the application is setting up, is creating the application logins, user roles, and is going to run some tests. And you can see here it completed 3 tests. Now, when the application was done, it has exited because the web app container is no longer a long-running process, and it just completed and exited here. All right. So I'm going to just exit this and tear it down. So there you go. I finished cleaning up my environment. I have a clean slate again. Right. So let's go back to our deck. All right. So what I just showed you was 3 ways on how you could use containers in your environment and back in your organization, and how some of our customers are building out a data as a service, and how their developers in those environments are using containers or using SQL Server on SUSE. Right. So one real world example of doing what I just showed you was actually our own team. Our SQL Server engineering team, when we build out each build of SQL Server, we actually spin up 700 container instances of that same SQL Server, and we run tests against it. We have about 60,000 tests and or more tests, so it actually takes quite a while to run. Now, because we could do this with containers, we only have to run this on approximately a 150 VM host in Azure. If we didn't run this in containers, we would have less density, so we would require more resources. So by running a database in a container, this could really help you save costs in your environment as well. So if you look at, for us, in some cases, in some test suites, we could run 20 instances of SQL Server on a single VM, right? As opposed to running just a few. Normally, as we did before, prior to containers. So this high density, what I showed you, remember the port mapping I just mentioned to you? We're doing the same thing where we map a different SQL Server instance on a different port in order to run this test, right? So, in terms of deployment, what I just showed you was some of the containers, but in terms of 2017, 2017 was the first version of SQL Server that we had available on not only Windows but on Linux as well, and a big part of it in a containerized environment, right? So also, we went through the zipper install effectively inside a container, but with 2017, our first version of our release, we didn't have every single feature, right? We have all the core engine features, but now we're taking it with 2019. We're actually taking it to the next step, where we're adding features such as replication, distributed transactions, poly-based machine learning services, improved AD configuration support, and much more. Some of these are which we're going to cover in the next section, actually. So remember in the beginning, we talked about how our customers are coming to us about two things. One of them is building a data as a service, and the other one is actually managing enterprise databases, where you may not only are you building a service to improve efficiency in your organizations, but you still have that need to run production environment data. So with 2019, we have a lot of new features that's coming in here, and I'm going to have Amit, who's actually going to demo this. I'll talk about this next section.
Yeah, so I'll quickly introduce myself. My name is Amit Banerjee. I work on the product engineering team as Vin. I lead product management for SQL Server, both on Windows and Linux. And one of the things that, before we started showing you demos of all the innovation that we're delivering in SQL Server, I wanted to take you through what we're actually doing with SQL Server 2019. And that's why we say it's data as a service and not database as a service, or not a particular database. How many of you have actually looked at SQL Server 2019 or gone through what's available? Quick show of hands. Okay, sort of. Okay. So there's 4 areas that I want to touch on which kind of sets Microsoft apart from its database offering. The first one is InMemory Database. We started that journey with SQL Server 2014, where we gave you the capability of creating procedures and tables which were in memory so that you don't have to go through the I/O path. But a common feedback that we got from our customers is that's a schema and application change. So every time you go through an upgrade, and Win was showing you how you can actually make upgrade code rollout much easier, but it still work. So if you have to go change an application schema and a database schema, there's a lot of tests, there's a lot of work that has to be done to de-risk that upgrade. So we're actually looking at creating synergy with in-memory technologies like Intel Optane with NVMe, so that you just don't use it as another storage device, because if you use it as another storage device, you just have a faster disk. You still have to go through the I/O path. So it's SQL Server 2019, we're actually removing the I/O path completely if the SQL Server database files are residing on a persistent memory device. So what that means is when you're actually doing an I/O, you're directly making memory calls. You're not even going to the I/O stack. So you're fundamentally changing the performance of your database without actually making a change to your application or database schema. So you're just changing, it's like changing storage, but instead of changing storage, it's a whole new world right now. You're actually moving from hosting your database files on a physical disk to a persistent memory device. So that just makes it fundamentally faster. And some of the recent benchmarks, and if you go around in the technology showcase, you will see our partners, HP, Intel, and Lenovo, showing you benchmarks that they've done with SQL Server where performance is significantly faster by just switching to a persistent memory device. The next thing is the database. The number of features that we have introduced in SQL Server and the number of configuration options just keeps increasing. And if you have to go through each of those options and remember which kind of query plans you need to look for or which query plans are potentials for going and optimizing, then the number of releases are also high. So you have to remember a lot of permutation. Okay, this works on 2016, this doesn't on 2017, but on 2019 this gets better. So the matrix can get very, very confusing. So with 2019, we have taken a step further in what we call the intelligent database. And if you follow generally the query performance and the query optimizer journey, it's a very simple step how query gets executed. I'm oversimplifying here. You submit a query to the database engine, the plan gets compiled, the compiled plan is used to execute the query. If you need to change the plan, you need to go recompile, right? Does everyone agree that that's the general oversimplification of how query executes? What if we said that that's not true? We are changing how the query optimizer works so that we know there are patterns which SQL Server can adapt on its own. So for example, if you're using a table, temporary table, you don't know what's going to be in the temporary table. So there's no way a compile plan can generate an optimal plan because there's no data in the temporary table, and during execution, you'll populate it. And that trips up a lot of performance tuning exercises because you don't really know what's going to be in the temporary table. How do you optimize for that? So if the plan is going to change right after you compile it, then what's the point of using that plan while executing when you know that that's a known pattern? So we're taking some of these patterns, and maybe some of them are also anti-patterns based on coding standards that have been established over years, and we're changing the compile plan without you having to recompile it. So in flight, so it's like sort of a little scary that the plane is actually being built while you're flying it. Not a real world practice, but yes, we're actually changing the compile plan at runtime and persisting it based on feedback loops that we're creating inside the database engine and based on patterns that we know that don't perform. So instead of going back and saying, guess what, this pattern doesn't work, change your query, we're taking steps to change it for you so that if you have a packaged application or if you don't have the ability to change your application code or the query that's coming in, then the database engine can lend a helping hand. The third thing, which I'm going to dive deeper into my demo, is in database ML. We are the only database, commercial database, that allows you to run ML right beside your data. And I'll come to why that's really important. And obviously, availability, performance, security, this is something that goes without saying, that if you are running a database and that is serving as the backend for a very mission critical or business critical application, performance, security, and availability are key things that you would look at. You wouldn't pick a small or a non-enterprise database to serve as a backend. So with that, I'll show you what we're doing in SQL Server 2019. We continue to give you choice, but on the first column that you see, intelligence over any data, we're hearing customers come in and tell us that I have so much data, I know I have a lot of insights in there, but I cannot access the insights because the query that I need to run on them doesn't scale, and I need to go build various different data lakes. And big data is a very big term. If you talk to any of our customers, everyone's talking about building their own data lakes. But the fact is that you have decades worth of data sitting in system of records. So are you going to spend time in taking that and building complex performant ETL processes to move the data into another data silo? Then that just becomes a data movement exercise. You're still not gaining value till you've actually created the data lake and build the compute engines on top of it. So we kind of realize that that's a conundrum that our customers have today. Do I go build efficient ETL processes so that in the future I'm set up for success? Or do I build my data intelligence or data analytics on top of the existing data platforms that I have? And it's not one or either. Every enterprise that we talk to has more than one data provider, has more than one type of technology that they use. They use relational, non-relational, more than one vendor for relational and non-relational. So there's a plethora of technologies out there and in a myriad of database technologies and data technologies that you can use to store and reason over your data. So what we're doing with 2019, and this is where it's mostly based on Linux, because big data and all the other capabilities that you see here, like things like Spark, those are native to the Linux ecosystem. And on the first side, SQL Server in Windows and SQL Server in Linux will be able to do the integration of all of your data, and sort of SQL Server would become a logical data warehouse. So you could actually do T-SQL over your data sitting in an Oracle database, sitting in an older SQL Server database, or even sitting in Cloudera, Hortonworks, or your own HDFS store. And if you have a need where we are not providing you a connector, you could actually even build your own ODBC connector to another data source that you have. So we sort of create, the feature is called Polybase, and we use virtual tables that you're building on top of external data sources, so that when a user or a developer is coming in to write a query, they're just writing T-SQL. We will convert the T-SQL to, if you're connecting to a Mongo database, we will actually convert that to the equivalent Mongo query and send it to Mongo and get the data back for you. What that also allows you to do in the logical data warehouse is all these security features, all these technologies that we talked about, all of those are available to you from within SQL Server. You can use the same RBAC for accessing it, because the entry point into these external data sources is just SQL Server. You're not really accessing your external data source directly. You're accessing a SQL Server. You can create role-based access controls. You can actually use the ML capabilities within SQL Server to score data sitting in an Oracle database or a Mongo store, or even Cloudera or Hortonworks data lake. So you can actually use SQL Server's inbuilt capability to do that work. Now, when the data size increases, obviously making these queries, like if you have, let's say, 10 years worth of sales data, doing a pass-through query is probably not going to be the most efficient form, because that's just going to be spinning. You could have a lot of coffees and lunches, and maybe your query will still be running. And that's not the most performant way if you're trying to build a near real-time decision-making system. So that's where the middle pillar comes in. For the first time, Microsoft will be shipping Spark and HDFS as storage options within SQL Server. So you would be able to land data inside a SQL Server environment stored natively in text or Parquet. You would not have to serialize and store it, or flatten it out and create a relational format and store it inside a database. You could still do that, because SQL Server will ship with database and relational storage capability. But at the same time, if you want to store unstructured data, you could store that directly in the HDFS layer that we will ship with SQL Server 2019. And this is all container-based, so you can scale up, scale down, however you see fit. The other thing that becomes very interesting is, now that you have data stored in HDFS, we will allow you to write SQL queries against that data. So you could actually do a select star, and if you have a Hive table named orders, you could do a select star from hive.orders. So that kind of changes how you're actually accessing your data in a data store. And you could take that select star from hive.orders and join it with a table that is stored inside SQL Server. You could say select star from hive.orders, inner join dbo.customer on particular key. So you could actually have data sitting in various different sources and shapes and forms where you don't have to do ETL, and you can just cache them inside SQL Server. We would provide scalable, and this is, again, a new thing for SQL Server. How many of you use SQL Server since 2012? Okay, a few. So you'd see column store indexes, which was a way for doing analytics. And that is a scale up. So if you had like resource constraints, you would add more physical memory, CPU for SQL Server to scale up. So the caching layer that we have built is on column store indexes, but it is a scale out capability. So you can keep on adding containers, and your data caching layer would scale out. So now SQL Server will have both scale out and scale up capabilities when it comes to data analytics. And because all of this is container-based, you can actually use Spark ML or R or Python to reason over any of the data. You can create models and create containers which operationalize those models. So you can actually call, like how Vin was actually calling a container for deploying a new app, you could actually call a container to do the ML work and just go away. So you don't have to have large compute environment just sitting there waiting for work. So when the work comes in, on demand, you spin up the containers, and which is super fast. You could actually go ahead and finish that work, and the containers just are ephemeral to just go away. Because the code will be sitting inside the SQL Server metadata, so it would know what algorithms it needs to spawn to go do that work. So let's go see that in action. So bear with me if things run a little slow. I'm, again, doing this on an Azure virtual machine inside a container. So I'm going to show you a database that I have. And this is the tool that which is multi-platform. So how many of you have seen notebooks or worked with Jupyter notebooks? OK. So we introduced a new concept in Azure Data Studio called T-SQL notebooks. Every time you do a database deployment, this is not just SQL Server, you have a bunch of scripts which you'll write automation for. But if you have to share results, you would have to store them in a separate file. So you'll basically send someone, hey, this is the kind of query that I ran. These are the results that I got. And you prettify it and send it so that people have a readable format. What if we could just put it all together? And which is what notebooks are for. Which is why people doing data engineering or data science like notebooks, because the instructions, the code, and the output is all sitting in one place. So I have this data called Lending Club. And the scenario here is that we had a customer that showed this where they did 1 million predictions per second. I'm not going to attempt to do that inside a container right now. But what I'm going to show you is the same concept, but inside a container running SQL Server on Linux using machine learning services on SQL Server. And the scenario that our customer had is they basically have a loan warehouse database. And the business users come in and they want to create promotions. They want to change metrics of the loan so that, for example, next financial year, we want to increase the APR because they were on a hybrid loan and their fixed period ended. So what percentage should the change be? And they want to model and see if we increase the APR or if we increase the interest rate, would the loans charge off, and how would my risk increase? So we have a R model that is sitting in there that is scoring the loans against a SQL Server table. So in this table, I have about, I think, 2,000 odd loans. So as you can see in the notebook, I'm able to look at all the different information, and obviously this is all anonymized, but I can see mortgages, loans related to rents, and what they have taken the loans for, and their current status. So this container of mine has 2 CPUs, so I'm not going to attempt to do 1 million predictions on 2 CPUs. That's probably not going to be the best use of our time here. But what I really want to show is the ML capability that SQL Server on Linux has. So I have this T-SQL stored procedure, and what this stored procedure actually takes as an input is 2 things: the starting ID of the loan and the ending ID, so that I can create a partitioned or a parallel scoring process. And because I've got 2 CPUs, I'm going to use only 2 parallel jobs to score the loans. And it's actually picking up the loans. So it's actually picking up various fields from my loan stats table. And then it is actually running an R script to score them. So this is the R script. And this is something that SQL Server introduced in SQL Server 2016. You can actually run R and Python. Python support was introduced in 2017. You can actually run these scripts from within SQL Server. So you're actually running it right beside your data. Your data is not really moving out into another machine learning server to do the scoring. So if you bring your scoring right next to the data, obviously performance is better because your data is stored inside the database. I'm speeding up performance by using things like in-memory OLTP and column store indexes so that I can process things faster and read faster from the database. And then what I'm doing is I am also storing the runtime statistics. So let me go ahead and recreate the stored procedure. It tells me that I just modified it. My server is in GMT, so you're seeing a different time here. And then I have a what-if scenario. What the what-if scenario does is it basically also does the same scoring, but it takes a input over here, the increment value that the user will provide. So the modeling is basically looking at if the interest rate increased, what would be the risk for the credit union or the bank that's giving out the loans. So let me go ahead and create that as well. And this is where we have actually started viewing Azure Data Studio as the development platform, because now I can actually open up a terminal session within Azure Data Studio and start a PowerShell core terminal. And I have two scripts. One that does the loan scoring. So what the loan scoring does, and this is a demo, so you can see my password, which is obviously not the ideal thing to do in production environments. But essentially, it's submitting two jobs, and it scored 1,000 loans, and I sped up the processing by using a column store index, which is actually reading data in a very compressed format. So I finished scoring all of them, and now I'm going to go run the what-if scenario. So let me go ahead and do that. So now what it's going to do is it's going to ask me how much you want to increase it, and I'm just going to say 9.5. And probably any bank that's trying to do that is probably going to get a lot of hate mail from their customers, but it's a demo. I can do whatever I want in it. So it finished scoring all of these loans, and it is storing the data inside the tables here. And these tables, just to make sure that I'm performant, I'm only storing the loan ID in there and the prediction value. And another thing that Azure Data Studio allows you to do, it allows you to actually quickly look at your data and visualize it. So for example, this is a standard group by query, but what I can actually do here is I can click on this button and I can look at a chart. And again, within the Data Studio, I'm actually looking at what are the different loan characteristics I have, and I chose a small number. But the easy thing is the data exploration that I have to do from within. I am not leaving the tool. I'm just doing everything within Azure Data Studio. And if you're more familiar with notebooks, then you can actually choose your kernel as well. So in my case, I'm using SQL notebooks, but you could actually use Scala or Python and operate against SQL Server. So now for the business user, they're not obviously going to use Azure Data Studio to get those insights. So we have this Power BI here. How many of you use Power BI? Okay. So Power BI is a data visualization service. We have a SaaS service that runs in the cloud. And then what I'm running right now is the desktop version. So I'm running Power BI Desktop. And you can see that this is the old value. So I'm going to refresh it. So what this view basically shows you is a distribution of where my loans are. And we have actually created a query which shows what is the risk charge-off or the risk probability for the loans being charged off. So I did that with 9.5%. And obviously, you can see that in Montana, there was actually no risk in the portfolio. But if they increased the rates by 9.5%, the risk obviously increases. So for the business user, this gives them a good ability to visualize. And all of this data that I'm actually pulling from is running inside a container. So the ML and everything is running inside a container. You could actually take this a step further. You can actually write containers which are also running SQL Server so that they pull the data out of SQL Server do the processing. In this case, the processing was fairly simple, and I was running a very rudimentary R script. But if you have really complex machine learning algorithms that you want to run against your data, it's probably better to have data marts created on which you run your algorithms. And SQL Server containers support persistent volumes. So you can actually create data marts on persistent volumes and turn off the containers to save on compute. And when the work comes in, you can restart the container, attach it to a persistent volume, do the work, and then go away. So it kind of, in demos, and this is, Vin and I joke about this quite a bit, that till we had container support in any demo in SQL Server, we wouldn't attempt to even set up a database because it just took too long, and you don't know if you would have enough time to go through the entire demo. And now we're just starting up SQL Server, installing it, configuring it, and showing you. And we can do this in a very repeatable fashion. And before I finish my chain of thought, the SQL Server instance is actually working. So let me go back to my deck and talk through the other slides that we have on what we are actually doing with SQL Server 2019 and what else is available. So the first thing that we would want to look at is if you see security as a prime tenant, so there's security, there's availability and performance, and I'll lead through all three. So I already talked about in-memory databases, and that could actually give you a performance boost for up to 30% for IO-intensive workloads. The other thing that we are actually doing with SQL Server and persistent memory is every database has a cache, and Oracle calls it SGA, we call it buffer pool, and Postgres also has a data buffer cache. And the idea of the data buffer cache is you actually use some variant of a least recently used algorithm to cache hot pages in memory so that you don't have to read from disk, and then you optimize it with read ahead and all those sort of things. But what if your data was residing on memory in the first place? So if you're in persistent memory devices, you're actually sitting on physical memory. You don't really need to create another cache and duplicate storage. So whenever we find that you have data residing on a persistent memory device, we actually remove the buffer pool for those data pages. So you're actually doing direct memory calls, which is significantly faster for clean pages. Obviously, if you're doing writes, we have to change them and write them back. But for clean pages, which you're not modifying, and that's essentially any read operation, and most databases have a higher bent towards reads than writes. So that actually, again, speeds up your performance for your existing database without changing any code in any shape or form. Then comes security. This is something that we have heard very, very loudly and clearly from our customers, that if you're encrypting sensitive data like credit card, PII information, the key and the store cannot be in the same place. Because that's kind of weird, right? You're giving it to the same admin that can compromise. I'm not saying people do, but from a compliance standpoint, you obviously have issues in passing compliance, and then you obviously have malicious actors that can actually act against you if you have data and the key that is protecting the data stored in the same place. So we introduced a capability in SQL Server 2019 called enclaves. So the general practice today in the industry is you store the key in a different place, you store the data in a different place, and you have to go to the key or send the data to where the key is stored so that it can be decrypted and sent back to you. That data round trip is actually not performant. So we introduced a thing called enclaves, and enclaves is a hardware capability which allows you to basically store or compute inside a chipset. So think of enclave as a secure computation area that no application, even with admin rights, can access. So you send the key and the data to be decrypted into the enclave, so that the application doesn't have any information about it, and you get back the decrypted data. So that way you can actually save on the round trip time for the database without having to actually store in 2 different places and take a performance hit. I already talked about Azure Data Studio. One of the things that I didn't mention that with R and Python in SQL Server 2019, we are adding Java support. Like you saw me writing T-SQL to run R code, you can now write T-SQL to run Java code. So you're actually extending SQL's extensibility layer, and we will also add support for UTF-8, which if you have like English collation or English code pages, and you're storing non-Unicode data, you can actually reduce your storage size by about 50%. So that obviously, with a data explosion that's happening in the industry, reducing your data footprint obviously helps. You saw Azure Data Studio. This works on Windows, Mac OS, and Linux. And one of the things that we have also started doing is the name is not SQL Server something. It is Azure Data Studio. Microsoft has other data services that we run on Azure, like we have open source databases, which is offered as a PaaS service, which is Postgres, MariaDB, MySQL. We have a NoSQL globally distributed store called Cosmos DB, and we also have a PaaS SQL Server, which is SQL managed instance and singleton databases where you only get the database as a service. So all of these capabilities needs a studio that you can connect to. So Azure Data Studio is that entry point, and we recently announced support for Postgres. So you can actually use an extension with Azure Data Studio, which would allow you to go access a Postgres instance that's running on Azure or somewhere else. So you can actually make Azure Data Studio your home for that as well. Any questions? So thank you very much for coming. We're going to be in the showcase.